All right. So, what we're going to be talking about today, class, is what we did today. Today is November 27th. This was the agenda for 11/27/2023. We did a review of a question on surface area. Picking things out, reminding myself the tools here. We reviewed a question on surface area. In first period, we made it through 5.1, the IXL, and example 2 notes. And in second, fourth, sixth, and seventh, we made it through the notes and the first IXL. Sixth period actually did get to example 2, but they've not done any of the IXL. We'll do some of that in class tomorrow. We'll have some time to work on IXL tomorrow in class. We're going to start off with just reviewing the review question. We wanted to be able to correctly identify and apply the surface area equation for this solid. We talked about it in class. We worked on identifying this shape. Well, plenty of you realized there were no squares on it, so it wasn't a cube. It was not a cube. We had 5 here and 2 here and 6 here. We gave it a name. We called it a, plenty of you recognized it, correctly identified it as a rectangular prism. And as it was a prism, we then worked to find we then selected the appropriate equation for its surface area. Equation for its surface area, as a note for us, from our reference sheet was SA for surface area equals 2 times capital B plus the perimeter times the height. Now, being able to identify this equation from your reference sheet is important, but more importantly is being able to apply it, figuring out what values get plugged in where. What's B going to be? What is capital P, the perimeter, going to be? What does H stand for in our equation? Well, first off, since it's a rectangular prism, we identified that the base was going to be the rectangle on the bottom. And we focused on finding its area, because B stands for area of the base. We said B was 5 times 2, which is just 10. We also identified the perimeter of the shape. We need the area of the base, which is 10. We also need the perimeter of the base. We need the distance around the bottom. That distance around our perimeter would just be 5 and 2, and another 5 on the back, and another 2 on the left. So altogether, 2 plus 5 plus 2 plus 5 is 14. Once we had that, we just got to plug basically some numbers in. We said our surface area was 2 times capital B being the area of the base. The area was 10. Plus the perimeter of that base, 14, times the height of the shape. How tall is the shape? From one base to the top, it is 6 tall. We just had to evaluate. It was just plugging in numbers into a calculator. 2 times 10, that's 20. 14 times 6, a little bit more difficult to memorize, but if you plug that into a calculator, as I would expect plenty of you will, you'll get 84. So we get the surface area altogether is 104. Now, we would like to put some units on this. So we see we're measuring in inches horizontally and inches this way, inches vertically. So we need to use inches, but it's also describing area. We're describing the area of a shape. We're not describing a length. If it was just a length, it would be inches. But we're not interested in length. We're interested in the area of the bottom. We're interested in area of the top. We want to know how much space we're taking up. Now, if we take a look at all the shapes, they're just little squares. So that's how we help name our shape. We name it inches squared. It might look like that. You might put a, let's see if I can do this. Nothing there. Inches with a power of 2, or you might have said the surface area equals 104. It's the SQ for square, IN for inches. Either of those would have been fine. We're reviewing surface area because there's going to be a quiz on Friday. Quiz Friday. And it will have a surface area question. From there, we took a look at our essential questions in our notes. Our first essential question for the day was, how are the interior angles of a triangle related? Some of you were able to remember this important fact. Basically, the one fact you need to know from today is the interior angles of a triangle sum to 180 degrees, or another way to say that is they add 280 degrees. What that means for us is we can find angle 1 and angle 2 and angle 3 just by writing a couple equations. We're able to say angle 1 and angle 2 and angle 3 in each triangle. Each triangle should add up to 180 degrees. So let's focus first on this triangle here, this LKM triangle. We can look at it and say we got 57 degrees. We've got 71 degrees. And we've got the measure of angle 2. Those three things together should make 180 degrees. So what can we do? We can just start by combining some like terms. 57 and 71, we can add that. We can get 128 plus the measure of angle 2 equal 180 degrees. And we just subtract. We would subtract 128 from both sides. We get the measure of angle 2 is 180 minus 128, which is equal to 52. And we wrote that down. How I wrote it down and how you wrote it down should have been very similar. We wrote down the measure of angle 2 was 52 degrees. We also looked at other facts. We saw we have angle 1 and we've got 57. Those two angles together are making a straight line. That was another convenient fact for us to then use. We said the measure of angle 1 plus 57 had to equal 180. Not because we have a triangle there. This isn't a triangle. No triangle right there. Undo that. This isn't making a triangle, but it is a linear pair. That's an important fact for us. Linear pair. And our linear pairs always add to make 180 degrees. So then we just subtract 57 from both sides. Measure of angle 1 should equal 180 minus 57, which we said was the same as 120. We wrote that down. We said the measure of angle 1 is 123 degrees. Last, there were a handful of ways to do it. We could focus on the triangle JLK, or we could focus on the larger triangle JMK. Either way works. What we're going to do, because there's always multiple methods, is we're going to focus on just the smaller triangle. We're going to focus on JLK. We know angle 1 is 123 degrees. We know this angle is 28 degrees. These three angles together should make 180. That's what we're saying here. The interior angles sum to 180 degrees. So we go ahead and write something like that. Say the measure of angle 3 plus the measure of angle 1 plus 28 equals 180. We know the measure of angle 3, or we know the measure of angle 1 is 123. So we just start subtracting things. Well, we will add two parts and then subtract them. We know 123 plus 28. We can add that in a calculator. We'll get 151 equals 180. Subtract 151 away. An answer of 29. There are multiple ways to get these answers. You have multiple methods. All you have to do is basically write this fact. Write down the fact that the interior angles sum to 180 degrees. Choose three angles that make a triangle and add them and set them equal to 180. If you find two angles that you don't know to begin with, look for another triangle or look for some other common facts. We're going to cover the second part of our notes in a separate video.